Welcome to FitrAI, created for the Congressional App Challenge by me, Cyan Rao, Austin Lin, and Jaden Chen. We use Python, JavaScript, and TypeScript for this. I will help work on the front end.
Hi, I'm Jaden and I do the backend.
I'm Austin Lin and I developed the front end of this project.
The problem that sparked the creation of the apps is the fact that 72 million people, almost 19% of the population in the United States, actively go to the gym, and that's a huge, substantial amount. And since COVID-19, this amount has increased primarily due to better focus on fitness and physical health. And a large portion of this growth is from young and inexperienced individuals who often don't know proper workout posture. In this illustration, you can see a bad form of a squat can lead to a lot more injuries because of strain on the back, legs, and other part of the body. And a lack of professional resources is naturally created because of how much more influx there is of young and inexperienced individuals, and this can cause a lot more injuries. And that's the purpose of our app. That's the reason why we created this. Our purpose is to make personalized, safe, and effective fitness training accessible to everyone, despite the circumstances and despite what kind of equipment and other stuff they have, using a multitude of technologies.
A general workflow for how our app is going to function starts off with taking in camera input from the phone's camera and then inputting those frames into a pose estimation algorithm utilizing MediaPipe's Blaze Pose to detect limb angles and lengths. Then using specially designed algorithms for the exercise that the user is trying to perform, we can then analyze those angles and lengths. Finally, using the data that those algorithms return, we can then relay back that information back to the user for feedback on their form.
For our app implementation, we first had a Python backend which used quite a few libraries. This included MediaPipe, which was used for pose estimation, OpenCV and NumPy, which was used for image decoding, adjusting, and formatting, as well as WebSockets for the connection to the front end. Meanwhile, for the front end, which was based on JavaScript and TypeScript, we used the framework Expo, which is based on React Native, as well as the React Native Vision camera for the video capture. For our database, we also had a library that integrated PostgreSQLite. Here is a diagram for our client/server pipeline, which explains how our video pipeline goes from the client to the server, and from the server with the post estimation back to the client.
Our app targets low-income households, those new to working out, and athletes. Thank you for watching.